Hey guys, so I'm totally doing subliminal advertising. I don't even know this guy. I saw a symposium once, but Richard Restak, I don't even know if I'm pronouncing his name right, but I saw a symposium and it was pretty dang cool where he talked about the brain and how people can um, examine the brain now and see how it functions and things. But check out the kid on the front cover. Doesn't he look like little Opie Taylor from Happy Days? No, well, later on Happy Days, but Andy Griffith's show. Opie Taylor, cute. So why am I bringing this up? Well, I'm going to exercise your brains with this problem here. Okay, so we're going to graph this quadratic. And if you looked at part 1, my leading coefficient in that guy was a 1. What happens if it's a 2? Okay, I'm going to show you a few things here, all right? If you looked at part 1, what we did on that one was we first found the y-intercept, and we found how it opened, whether it opened up or down, and we found out the axis of symmetry and the vertex and x-intercepts and etc., etc. I'm going to show you a couple more things here, okay? So first, let's find out what the y-intercept is. That's usually pretty easy. Hopefully you know what to look for now. And I explained this in part 1, but basically it's 0, comma, that value, okay? When it's written in standard form. If it's in vertex form, game changes a little bit. More on that in a few minutes. All right, how does this open? It's a positive leading coefficient, so it's going to open up. If it was negative, it would open down. All right, let's go after the axis of symmetry. I'm going to go a little bit faster this time than I did in part 1, so if I'm too fast for you, back up and take a look at part 1. In part 1, I mentioned this vertex formula, x equals negative b over 2a. So it's a negative of 2 over 2 times this 2. That's a negative 2/4 or negative 1/2. So x equals negative 1/2 is my axis of symmetry. Let me plot things as I go here. 0, 5, 1, 2, 3, 4, 5. My axis of symmetry is negative 1/2. So I'm coming down through here a little bit. This is the x-axis, this is the y-axis. I should have done this in part 1. I didn't. These hash marks are 1 unit each. Okay. All right. Okay, let's go after the vertex. Vertex is going to be a little challenging now because I'm using a fraction this time. So if x is negative 1/2, what will y be? So 2 times a negative 1/2 quantity squared plus 2 times a negative 1/2 plus 5. So let's do the exponent first. Negative 1/2 squared, that's 1/4. Okay. Now let's do the multiplication step next. 2 times 1/4, that's 2/4 or 1/2. Minus, this is going to be negative 2 over 2. You know what? I'm going to leave that as negative 2 over 2 because I'm going to have to get a common denominator here anyway. Plus 5, but instead of 5, I'm going to write that as 10 over 2, right? 10 over 2 is the same thing as 5. I'm trying to save myself a step here because my board's only so big here. Got common denominators here. 1 minus 2 is a negative 1, plus 10 is a negative 9. So negative 9/2. So my vertex then is my negative 1/2, comma negative 9/2, which negative 9/2 is like a negative 4.5. So 1, 2, 3, 4.5. Looks like I'm down here for my y-intercept. Okay, x-intercepts. Trying to remember if they're going to be nice this time or not. Will I have x-intercepts? First of all, yeah, I will. I don't think they're going to be very nice to find. They're going to be fractions or something. So, you know what I'm going to do? I'm going to use the discriminant. There's a blast from the past. Remember b squared minus 4ac? So, let's find out. I'm going to make use of that guy. Let's see what happens here. Okay. A is 2, B is this 2, and C is this 5. So that's going to be 4 minus... Son of again, something's not right. And I found it. Okay, that should be a positive 9 halves. Okay, I knew something was wrong. Here's how I knew something was wrong. Okay, I'm gonna make my mistake work for us here. Okay, so if you were watching and you saw me getting a negative here, you're probably over there laughing at me. Yeah, even myself. 20 times 2 is 40. So 4 minus 40 is a negative 36. So the discriminant here, I'm making this thing work for me. So this is wrong. If I get a negative out of my discriminant, that's going to mean that I do not have any x-intercepts, right? And that's why I was like, yeah, that's really skinny. Are you sure you did that right, Ben? And so I came back, and that's where I found my error, because this should be negative 1/2, comma, positive 9 halves, or 4 1/2. 1, 2, 3, 4 1/2. So I'm up here. So look at what's happening. Axis of symmetry. I think I talked about this in part 1. The distance from my y-intercept to my axis of symmetry is 1/2, right? So let me come out another 1/2 to here. So as you can see, my graph is actually doing this. I do not have x-intercepts. See? It's opening upward, and my vertex was already above the x-axis. That's how I knew it was not going to have any x-intercepts, and I used the discriminant to verify that. So that took care of that. So this problem is done. Let me go ahead and save this. Part 3, I'm going to do the same problem. I think what I'm going to do is I'm going to erase everything except for some key elements here, okay? I'm probably actually going to keep my y-intercept, keep my vertex, and my axis of symmetry, and I'll probably keep my graph, but I'm going to erase everything else and show you something in part 3 that I think you're going to find useful, especially if you're taking college algebra, all right? So hang tight.